Good afternoon, my diligent pupils, and welcome to another engaging episode of Mr. J's Masterpiece Theory. Oh, the semester that we've had, from studying Periton's organum to the delights of the Renaissance madrigal, from the Baroque styles of Bach and Handel to the programmatic stylings of Berlioz and Dvorak. And let us not forget Haydn's humor. We have indeed traveled through time, becoming more aware of our comprehensive view of music. Mr. Johnson, there I go again. I apologize. I am painfully aware that the level of long-windedness is directly correlated with the level of music dorkedness. I am happy to report, however, that today my nerd factor will not be limited to music alone, but will include math as well. As you watch the following material, I hope you will become more aware of the power of numbers through music and the somewhat unpleasant sounds that accompany it. Well, now that I have you bursting with enthusiasm, it is my honor and privilege to introduce you to the thrilling world of musical serialism. Now, before we begin, we must address a few items. First of all, do not eat the cereal. Steely Dan, you ate some already, didn't you? Well, if that's the case, then you can go get some additional cereal from the box in the front of the room. Furthermore, we must establish a general understanding of both the social and historical contexts through which this musical style came to fruition. I assure you it is a most charming tale, filled with both musical wonder and mathematical equivalence. As we have already discovered in our musical journey, the original style of classicism, developed in the 18th century, focused on order, symmetry, and balance. It was designed to be emotionally detached, more objective, and focused on structure and form rather than aesthetics. The 20th century neoclassicist movement took this ideal to the extreme, utilizing mathematical calculations as the basis for compositional style. As we learned previously, Haydn, Mozart, and Beethoven were the original founders of the Viennese school of classicism. The second Viennese trio included 20th century composers Schoenberg, Berg, and Webern. Although creating a melody can be done quite simply, in this case, several variables must be considered. 12, to be exact. There are, in fact, 12 steps to creating a 12-tone composition. And I shall boldly lead you through the first 5. The first step of this process is to create your original row. So I'm going to ask that you take out your baggies with these wonderful shapes of the Lucky Charms cereal and organize them in a way that you find aesthetically pleasing. The only thing that I'm going to ask is that you start with this shape here. Other than that, sky's the limit. And keep in mind that there are a finite number of possibilities. So be discreet. Now I know what you're thinking, Mr. J, you're such a square. But let's not be irrational. It is important that your row is unique to you. For example, I am sure Meadows is trying to think of the most logical way to organize her cereal row. Relax, Lorne, it doesn't have to be perfect. While Hannah Banana is undoubtedly trying to find a connection between the order of her shapes and some famous author or literary figure, what kind of cereal would Robinson Crusoe have liked? What about Hawthorne or Agatha Christie? What does that mean existentially? I would presume Emma's dilemma is figuring out how to make her row stand out in some brash and garish fashion. But regardless of how you choose to organize your row, you must now convert your shapes into numbers using the following conversion chart. So here you can see how I have organized my row. Like you, I started with the green four-leaf clover at the beginning. But other than that shape, the rest of these will be a different order for you than they were for me. But what I would like for you to do is assign the same number that I have to each shape. So, you're going to all start with 0 in the first box, as I have here. Wherever your pink heart is, whether it's in this second box or whether it's in this box over here, you're going to label that shape as 1 in the corresponding box. Wherever your purple horseshoe is, you're going to label that as 2. Your orange Cheerio will be labeled 11. Your green Cheerio labeled 10. Your purple Cheerio will be labeled 8. Your white with orange marshmallow thingy will be labeled 4. Your red Fruity Cheerio labeled 9. Your red balloon will be labeled 3. Your blue moon labeled 6. Your beautiful rainbow will be labeled 5. And your pot of gold will be labeled 7. Once you have all of those labeled, in this first row labeled P0, your prime row, you should have no repeated numbers. And you should have every number between 0 and 11. My numbers ended up being 0, 1, 2, 11, 10, 8, 4, 9, 3, 6, 5, 7. Unless you're a cheat, a horrible copycat, you should have a different organization of those numbers. But they should be the same numbers. Now that you all have a beautifully structured row of numbers, we need you to invert that row. But Mr. J, I don't know how to invert a row. Well, there's a very simplistic mathematical method for doing so. Simply subtract each number from 12 and you will have the inversion, or I0. John, are you having IO shoes? If so, let me provide an example of how this process works. So you will see, again, I start with 0. And in P0, box 2, I have a 1. I subtract 1 from 12 and get 11. So as I continue down I0, this row, the inversion of P0, how did I get 10? Well, in box 3, I had a 2. 12 minus 2 is 10. So 1 comes from 12 minus 11, which is 1. 2 and 10, 4 and 8, 8 and 4, 3 and 9, 9 and 3, 6 and 6, 7 and 5, 5 and 7. So all of these add up to 12. There is a pair that added to 12 in each of the inversion boxes. So now if my P0 is 0, 1, 2, 11, 10, 8, 4, 9, 3, 6, 5, 7, my I0, or the inversion of that row, is 0, 11, 10, 1, 2, 4, 8, 3, 9, 6, 7, 5. Make sure your P0 is the exact inversion of I0. And once again, in I0, you should have every number between 0 and 11 and no repeated numbers. Now, step 4 is a bit tricky, so listen carefully. What you are going to do now is to complete your matrix. In order to do that, you need to add the numbers together in each set of boxes to create an entire matrix of numbers. It is important to remember that all numbers must be between 11 and 0. So if you get a number that is greater than 12, that means that that note is an octave away from a different pitch. That means you must subtract 12 from that number to get your original number. So, for example, if I wanted to create a row starting at 5, so this is my row of notes. The 5 half steps up from my original note is here. If I wanted to start a note
on 5, I would need to figure out what this entire row would be. So in order to do that, I'm going to take this plane here, which is 11, and I'm going to add that to this plane here, which is 5. When you add 11 plus 5, you get 16. Because 16 is greater than 12, that means it's above an octave. So you need to take that note an octave down. In order to do that, you subtract 12. In that case, it would be 4. So 11 plus 5 minus 12 is 4. Then you go down the row. P10. 10, 5 is 15, minus 12 is 3. Starting at P1, 1 plus 5 is 6, and that's below 12, so you leave that alone. 2 plus 5, 7, and then so on and so forth. You get 9. 8 plus 5, get 1. 3, 5, 8, 9 plus 2, 9 plus 5 minus 12 is 2. 6 plus 5 is 11, and then 7 and 5 is 12, minus 12 is 0. Notice that if you do this correctly, you will get a diagonal line of 0 straight through the middle of your matrix, because you will have 11 plus 1 is 12. 12 minus 12 is 0. 10 minus 2 is 12, minus 12 is 0. 1 plus 11, 12. 2 plus 10, 12. 4 plus 8, 12. 8 plus 4, 12, and so on and so forth. If you calculate this correctly, again, you should have a diagonal line of zeros straight through the middle. Now at this point, I'm going to ask the sub to push pause so that you can calculate your entire matrix. When you are done with this process, you should have I through here, each inversion, starting on each note of the scale. You should have the original rows starting on each note of the row. You should have a retrograde, which means the reverse process, reading each row backwards. And then the retrograde inversion, which means you're going to take the inverted rows and do those backwards, reading from bottom to top. Once you're done with this process, you're going to fill out your chart for P0, which for me is right here, and for you it will be right there. I5, which for me is here, for you it will start in a different place, wherever your number 5 is, that row. R7, which means you're going to take this pattern here, P7, and do it backwards. And then RI10, wherever your 10 is, you will read that backwards here, from bottom to top. So pause this, fill out your chart, and then when you are ready, we will continue on to the next slide. The final step for us today will be to convert your numbers now into actual musical pitches. In order to do that, you will need to use what we call a pitch class circle for music notation. Whatever note 0 is will be the first note of your pattern, and then the chromatic scale will go up by half steps, 1, 2, 3, all the way to 11. Now you can start